In problem number 13, we are asked to identify critical points on the contour plot of a function. Of course, you probably know that the critical points of a function are points where the partial derivatives, all partial derivatives of first order of the function are equal to 0. But we're not given the equation of the function here, so we can't use that definition to find the critical points and determine them. However, we're given here the contour plot, and one way to approach this problem is to realize that critical points are special points for a function. They're not like other points. And so if you look at this contour plot, try to look at it and see, are there any points on this contour plot that stand out to you in a way that makes them different from other points. Now, one thing that you will probably see here is the concentric contours getting closer and closer to a certain point. So I'm talking about this area of the contour plot. There's a whole bunch of contours getting smaller and smaller and smaller, and they shrink to a certain point. Of course, not all contours are drawn, and so there probably are some more here. Now, we don't know exactly where that point to which they shrink is located. It could be anywhere inside that last contour that is given to us, but we do know that there will be a point towards which these contours shrink. So it could be maybe here, and the picture may be looking like this, or it could be somewhere else inside that last contour that's given to us. So this is one critical point, somewhere there, exactly where we can't pinpoint, but somewhere there there is one critical point. And then the second critical point is the point where the level line self-intersects. I'm talking about this point right here. Actually, maybe let me use a different color so that it's easier to see these points. So there's one critical point somewhere here, and then the second point is right here. Now, all other points, they're not in any way distinguished from other points. So for example, if we look at this point, well, this point is located on a contour line, and it doesn't look anything different from, let's say, this point or this point or that point or even this point. And so, and if you take a point somewhere here, for example, well, there's another level line that goes through that point like that. And so if you look around each of these points and the structure of level lines around them, you will not see any difference. They all look the same locally around those points. But let me give these points some names. So point A and point B. But the point A and point B, they look different from other points on this plot because, for example, for point A, if you look at the small neighborhood around this point, you see there is a self-intersecting level line that makes an X crossing, and that does not happen at other points on this plot. So if you look around this point, well, there is no X there. There is no level line self-intersecting at that point. In fact, there is no, for this point right here, there is only one contour line going through that point. No other contour line goes through it. Now for point B, what point makes point B different is that the point B is its own level line. All right, and also in a small neighborhood, if you look at a small neighborhood around this point B, you will find a whole bunch of level lines completely enclosed inside that small neighborhood, and they get shrinking. So there are two critical points here. We can even describe what kind of points these are. Point A will have to be a saddle point. And then point B is going to be either a relative maximum or relative minimum. We don't know which one, because on this plot the contour lines are not labeled, and so we don't really know what happens to the values of the function when we approach point B. Do they decrease or do they increase? Overall, two critical points on this contour plot.